All right, welcome to lesson 7.2. We're going to be multiplying and dividing radical expressions. That's what the objective is. That will also involve us simplifying, part of the objective as well, simplifying radical expressions that don't work out perfectly like we did in lesson 7.1. So let's first talk about multiplying radical expressions here. The definition there is the nth root of a multiplied by the nth root of b is equal to the nth root of ab. So when you've learned how to multiply square roots together, I'm assuming at this point, you just multiply the radicand together, the number under the radical, right? That works no differently when it's cube roots or fourth roots or fifth roots or any higher degree. What's key is notice that the index needs to be the same, right? That's what you're getting out of that definition there. So you can multiply square roots together, you can multiply cube roots together, but you can't multiply a square root and a cube root together. So in order to multiply radicals together, the index has to be the same. All right, so for the first one here, multiplying square root of 3 and square root of 12, well, because the index is the same, you get square root of 36. Square root of 36 can be simplified, right? That is a perfect square, so the square root of 36 is 6. Okay. Cube root of negative 16 times cube root of 4. They are both cube roots, so you can multiply these together. Negative 16 times 4 is negative 64. So you get the cube root of negative 64. A negative under an odd index root is okay. The cube root of negative 64 is negative 4. A negative under an even index root, like a square root, like you're going to see in example C here, is not okay. So yes, you could multiply these together based on the rule that we just talked about, but square root of negative 4 is imaginary. So we're not going to, well, all right. I was just checking to see if the direction said real, but implied is that it needs to be a real number here. We're not using imaginary numbers at this point, so this would just be undefined. There you go. Cube root of 3 times cube root of 9, negative 9. Again, negative's okay underneath an odd root. So 3 times negative 9 is negative 27. Cube root of negative 27 is negative 3. All right. Same thing that happened in C is going to happen in E. Cannot have a negative under an even root, so this is undefined. Doesn't matter that part of it's okay, since part of it is undefined. The whole thing's undefined. Here, index is not the same, so you can't multiply these together. However, part of it can be simplified, so you still need to do that. Square root of 16 is 4. And then cube root of 4, you can't do anything with that. So we'll just leave it as 4 times the cube root of 4. So again, you can't combine them, but you can still simplify part of that, so you need to at least do that. All right, let's look at the next part here. Now we're going to be simplifying expressions that are not going to work out perfectly. So you have, I'm sure at this point, at some point, simplified radicals, simplified square roots that are not perfect squares. And what you do is you break the numbers or each part into a square factor and a non-square factor. So 50 can break into 25 and 2, where 25 will come out, 2 will stay. You can do the same thing with x to the fifth. X to the fifth is not a perfect square, but it has a square factor. It actually has multiple square factors. The biggest square factor is x to the fourth. And when you break it into x to the fourth and its other factor would be x, right? Because those two multiply to x to the fifth, the x to the fourth will come out and the x will stay. So square root of 25 is 5, square root of x to the fourth is x squared, and then you end up with square root of 2x. Ultimately, when you're breaking down a variable with an exponent, you're looking for the biggest multiple of the index. So the biggest multiple of 2 that's less than or equal to 5 is 4. Okay, and then we'll look at that over here as well. For a cube root, it's the same process, except we're not looking for square factors, we're looking for cube factors. So at this point, you probably have the square numbers. You're a little more familiar with that, but let's write out the square numbers as well. All right, so for square roots, square factors are, well, 1 squared is 1, but that's not helpful. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. That's the 25 used over here. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We could keep going, but at least that gets you started. For a cube root, those numbers aren't helpful because we're not looking for square factors, we're looking for cube factors. So let's write those out as well. 2 cubed is 8. 3 cubed is 27. Notice how these are going to get bigger a lot faster. 4 cubed is 64. So that actually is a number that is in both, but that's just more coincidence because 4 squared is 64. 4 cubed. 8 squared is 64. 4 cubed is 64. Anyway, 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And then 10 cubed is 1000. So those are the numbers you should be looking for here. When you have a number like 54, you only need to check the numbers that are less than 54. So 54 is not divisible by 8, but it is by 27. So you can break 54 into 27 and 2. All right, so again, we're just looking at all the cube factors. Can 54 break down into a factor of one of those and something else? In this case, it can, 27. For n to the 8th, I'm looking for the biggest multiple of 3 that's less than or equal to 8, and that number would be 6. So my factor pair would be n to the 6th and n squared, where n to the 6th will come out and n squared will stay. The cube root of 27 is 3. Cube root of n to the 6th is n squared. Then that 2 stays under the radical, and that n squared stays under the radical. And that's your answer, 3n squared cube root of 2n squared. 18. So looking up at our list of cube numbers, does 18 have a factor of any of those numbers? Well, the only one it could is 8, because 27 is bigger than 18, so 27 can't be a factor of 18. So you can eliminate everything bigger than 8. 8's the only one that works. Is 18 divisible by 8? And the answer is no. So then that means that 18 stays. All right, you can't break up the 18. X to the 4th, what's the biggest multiple of 3 less than or equal to 4? And it would be 3, right? So it's x cubed, and then x, the first which is x, right? So this is the only thing that will come out. So you have x cube root of 18x would be your simplified version of cube root of 18x to the 4th. Switching gears back to square roots, you got to make sure that you're using the right list, right? So 50, well, we already did one that had 50, but since it's under a square root, I'm looking at the square number list. 25 is a factor of 50, so I'm going to break up 50 into 25 and 2. X to the 4th itself is a perfect square, so I don't need to break it up. You only need to break up the variable or the number if it's not a perfect version of the index that it's under. So square root of 25 is 5. Square root of x to the 4th is x squared. And then it's square root of 2. And again, there's no x under here because the entire x to the 4th factor came out completely, right? There is no x left over. So that's why there's no x left under the radical there. Okay. When you know how to simplify expressions, you can also simplify the products of radicals. What I would do, like, two trains of thought here. You can either simplify first and then multiply, in which case you might still have something to simplify at the end, or just multiply it together and then simplify at the end. I'm going to simplify first just because the numbers might get a little bigger, but you can certainly not simplify at the beginning and then just simplify at the end. All right, so 54 can break into 27 and 2. 27 was one of our cube numbers. X squared, can't do anything with that. Y cubed is a perfect cube. So when I simplify that, I get y on the outside. Well, I'm sorry, let's do that. Cube root of 27 is 3. Cube root of y cubed is y. And what's left over is 2x squared. Now, on this side, 5 can't do anything with that, right? X cubed is a perfect cube. That'll come out. Y to the fourth breaks into y cubed and y, where the y cubed will come out. So when I simplify this one, cube root of x cubed is x. Cube root of y cubed is y. And what's left over is 5y. Now when I multiply, you multiply the coefficients together, and then you multiply the radicands together. And again, you can only multiply the radicands if the index are the same. So 3y times xy is going to be 3xy squared. And then under the radical, you have 2x squared times 5y. So that'd be 10x squared y. There's nothing left to simplify, so at this point, we're done. Okay, with this one, let's do the same thing. 25, nothing to do there. 25 is a square number, so that you might think, okay, maybe I can do something with that, but you can't with this one. It's under a cube root. Nothing to do with x, and then y to the eighth you can break up, right? The biggest the biggest multiple of 3 less than or equal to 8 is 6. So y to the sixth and y squared. So y to the sixth will come out, and you get y squared. Cube root of y to the sixth is y squared. And then you have cube root of 25xy squared underneath the radical. Over here, nothing to do with 5. X to the fourth can break into x cubed and x, where x cube root of x cubed will be x. Y cubed itself is a perfect cube, so that'll come out as well. Cube root of x cubed is x. Cube root of y cubed is y. And what you're left with is cube root of 5x. Now when I multiply, on the outside, y squared times xy is going to be xy cubed. And then on the inside, 25 times 5 is 125. X times x is x squared. Y squared times no y's is just going to be y squared. Here you do have another step to simplify, because now once you multiply them together, that 125 is now a perfect cube. The x squared and the y squared can't do anything with that. So cube root of 125 is 5. That'll just come out as part of the coefficient. And you end up with 5xy cubed, cube root of x squared, y squared. Last one here is our square roots. So again, I would simplify first, but make sure that you're doing it as a square root, not a cube root, right? So x cubed is not a perfect square, but it has a square factor. And I'm sorry, 7, nothing you can do with 7, right? And then over here, 21, not a square number, but x cubed can break into x squared and x. And then y squared itself will be a perfect square. So now when I simplify on the left side here, 3 is already out there. Square root of x squared is x. And then what's left over is square root of 7x. Then over here, you've got 2. Square root of x squared is x. Square root of y squared is y. And then what's left over is 21x. Now when I multiply, 3x times 2xy is 6x squared y. 7 times 21, now on the inside, 7 times 21 is 147. And x times x is x squared. 147 is not a square number, but it has a square factor, which is 49. And then 3 would be the other one. X squared itself is a perfect square, so there is more simplifying to do here. Square root of 49 is 7. That'll multiply the 6 that's already out there and make it 42. Square root of x squared is x. That'll multiply that x squared and make it x cubed. That y is still out there, and this 3 is what's left over. So your answer is 42x cubed y square root 3. All right. Now dividing. Works kind of the same. As long as the index is the same, you can divide. And it's interchangeable whether it's one fraction underneath one radical or the radical of the numerator and denominator separately. So example 4 here, divide and simplify, assume all variables are positive. All right, so cube root of negative 81. Cube root of negative 81 is, well, pardon me, is not a perfect cube, but I can split that into negative 27 and 3, right? So cube root of negative 27 is negative 3. And then that 3 has to stay. And then down here, you've got cube root of 3. Now the cube roots of 3 are going to divide away, and you're left with just negative 3. All right, 12 can break into 4 and 3. Now we're talking about square roots, right? So 12 has a square factor of 4. X to the fourth is a perfect square. So when I simplify that, I end up with square root of 4 is 2. Square root of x to the fourth is x squared. And then square root of 3 is left behind. All divided by square root of 3x. So the square roots of 3 can cancel out, and you're left with 2x squared over square root of x. We cannot leave a radical in the denominator, so we need to rationalize. When you have a square root, you multiply it by itself, and you end up with 2x squared square root x, all over x. In which case, the x squared here and the x here, I can take an x away, right? So that's gone and that's gone, and you end up with 2x square root x. Probably not the easiest way to do it. So actually, I'm not going to stop the video, but here's another way to think about this one. Divide first. All right, so let me just rewrite that over here. You got square root of 12x to the fourth over square root of 3x. You can divide first. So like 12 divided by 3 is 4. And x to the fourth divided by x is x cubed. And now you can simplify that instead of having to rationalize. So square root of 4, 4 is a perfect square, so that'll come out. And then the x cubed breaks into x squared and x, where x squared is a perfect square. Square root of 4 is 2, square root of x squared is x, and then that x stays behind. So I'm getting the same answer, just the way I did it the second time is probably the easier way to do it. So divide first. Let's look at that for part C here. So divide first. 192 divided by 3 is 80. Let me work it out on my calculator, sorry. Is it... Huh. One sec. All right, 64. I don't know why I can come up with that on my own. Anyway, so you get now cube root of 64. X to the 8th divided by x, subtract the exponents. So it's as if there's an exponent of 1, so it's x to the 7th. Now we can simplify. 64 itself is a perfect cube. X to the 7th breaks into x to the 6th and x. Cube root of 64 is 4. Cube root of x to the 6th is x squared. And then that x has to stay. Okay. All right. Now we do need to do some rationalizing. So this is what I was getting into on the last one. When you can divide and it eliminates the denominator, that's the easier way to do it. It's not always the case, so you might need to do some rationalizing. So here, 3 and 5, there's nothing to take away, right? So I need to rationalize. I cannot leave square root of 5 in the denominator. So I rationalize a square root in the denominator by multiplying it by itself. Multiply by root 5 over root 5, and you end up with root 15 over 5. All right. Essentially the same thing is happening here. I'm going to rewrite it based on the definition that we talked about at the beginning, where I'm just going to write the radicals separately. Right? Again, can't leave square root of 5 in the denominator, so I'm going to multiply it by itself. You end up with square root of 35 over 5. Works very similarly when there are variables involved. But with this one, I would simplify first before I start rationalizing. So between 2 and 10, you can divide a 2 away. That'll turn into 5. Between x cubed and x, you can divide an x away. So that'll turn into x squared, and that x is now gone. So what you have is the square root of x squared over the square root of 5y. Well, quickly, the square root of x squared is x, right? So now I have x over square root of 5y. But I can't leave 5y under a square root in the denominator. No different than when I had square root of 5 under a denominator, or as a denominator. I multiply a square root by itself, x times square root of 5y is going to be x square root of 5y, and then square root of 5y times square root of 5y is 5y. Okay? A little trickier when we're talking about cube roots. Well, divide where you can first. So between a 4 and a 6, you can divide a 2 away, right? So this will turn into 2, this will turn into 3. I would do that first. So now you've got cube root of 2 divided by cube root of 3x. Cube root, you can't just multiply it by itself, right? Because I'm going to write this down. You don't need to write this down. If I multiply cube root of 3x by cube root of 3x, I can do that. But I end up with cube root of 9x squared. I still can't simplify that because those numbers are not cube numbers. The reason why square roots work is because when you multiply two square roots together, or a square root by itself, you create a square number under the radical, and then the square root of that just becomes itself. A cube root, I need to multiply it by something to make it a cube number. So 3 multiplied by 3 gets you 9. But I need to multiply it by a number that would make it a cube number. 3 cubed is 27. So if I multiply 3 by 9, I will make it 27, which will be a cube number that I can take the cube root of. X, if I multiply it by itself, I get x squared. That's no good. I want it to be x cubed. So I'm going to multiply x by x squared. So you can do that as long as you multiply the numerator by the same thing. Now when I multiply across, up in the numerator, I have cube root of 18x squared. In the denominator, I now have cube root of 27x cubed. The reason why we did that is the cube root of 27 is 3, and the cube root of x cubed is x. And the numerator is what it is. You can't do anything with that. All right, so that is how you rationalize with cube roots. Give the exit ticket a try, and then we'll go over that tomorrow and start the practice. So let me know if you have any questions. Like I said, we'll go over all that tomorrow, but try the exit ticket now, and then we'll go over it tomorrow.